In this tutorial, in this video, I will give an overview of how you can communicate with NI DAQ devices in the LabVIEW programming environment. In order to do that, you typically need to first install a driver called DAQmx, and then of course you need to have some DAQ hardware from National Instruments, and then you are ready to start using the LabVIEW programming environment in order to communicate and get data from your DAQ device. Here's an overview of the contents. I will first give a short introduction, then I will provide some practical examples. In this video I will focus on a DAQ device called USB 6000X. Here you have different options. You have 6001, 6002, 6008, 6009, etc. And then I will provide some different LabVIEW examples how you can communicate with that DAQ device from the LabVIEW programming environment. So let's start with an introduction. So in order to use DAQ hardware in LabVIEW, we need to use this DAQmx driver. This DAQmx driver is free to use. You can download it for free from internet, but of course you need a valid license of the LabVIEW programming environment. I will focus in this tutorial to use the following DAQ hardware because this is the devices I have here in my hand. I have a so-called TC01 thermocouple temperature device, and I have a USB 6008. But then you have this USB 6000 series where you have 6001, 6002, 3, 4, etc. These devices works in the same manner, and they have both analog and digital channels. But of course you can use other DAQ devices from NI, because all the DAQ devices from the NI company will work in the same manner, and they all use this DAQmx driver. If you have DAQ devices from other vendors than NI, you cannot use this DAQmx driver, because the DAQmx driver are only for hardware created by NI, but the principles I will show here in this tutorial will of course be more or less the same. So as mentioned, NI has lots of different hardware that you can use in combination with the DAQmx driver. I guess they have hundreds, possibly thousands of different versions and devices that you can use. I will just give a short overview of two different types, which is the devices that I have here in my office. The first one is TC01 thermocouple. This is a simple DAQ device with only one channel, an analog input channel. And you can connect a thermocouple temperature probe, and then you can use that in LabVIEW in order to read temperature values from this thermocouple probe. The other one I will use and give an overview is this USB 6008 DAQ device. This is the DAQ device I have in my office, which I will focus on in this tutorial and in this video. But there are lots of other similar DAQ devices from NI that you can use as well. And NI has also this USB 6000X low-cost series. Then you have USB 6000, USB 6001, USB 6002, and USB 6003, etc. These are low-cost DAQ devices, but all of them has more or less the same functionality and features. They have analog inputs, they have analog outputs, and they have digital inputs and outputs. So I will focus on these devices, the TC01 thermocouple device, which you find here, and the USB 6008, which you see here. So they can both be used in LabVIEW and by using this DAQmx driver, and they can be programmed in the same way, but the main difference is that this TC01 thermocouple has one analog input channel, and in that channel you just connect this thermocouple probe, while this USB 6008 has more options. It has analog inputs, analog outputs, it has digital inputs and outputs. So here on the left side you have a connector where you can connect different types of sensors, etc. While on the right side you have the digital channels where you can also connect different physical components. So in this video I will focus on this one, and I will also focus on reading values. So I will focus on analog inputs when I'm demonstrating this device in the LabVIEW programming environment. So when it comes to the software, of course you need the LabVIEW programming environment, and then of course you need a valid license for that LabVIEW software. In addition, you need to download this DAQmx driver. You can find it on the internet. You can either just Google it and then you will find it, or enter this URL and then you will download the latest version of this NI DAQmx driver software, and you can use this for free. But of course you need to have some kind of DAQ device, a hardware device that you can use in combination with this NI DAQmx. So after you have installed this DAQmx driver, then part of that software is the so-called Measurement and Automation Explorer. This is a separate software, so you can just in your search menu in Windows you can just type MAX, and then this Measurement and Automation Explorer will pop up. Basically it's a configuration tool that you can use to configure and test your hardware devices. So that's handy to use when getting a new hardware, and then just to use that tool to check that everything is working as expected with the hardware. You can also change the name for the device, etc. Next, when you have used this Measurement and Automation Explorer and tested your device and make sure that everything is working with your hardware device, then you are ready to start using the LabVIEW programming environment. And as part of the LabVIEW programming environment, on your block diagram, then you on the tool on the functions palette, which you find when you right click in the block diagram, you will find this DAQmx sub palette where you find all the functions that you need in order to configure and program your DAQ device in the LabVIEW programming environment. So now we are soon ready to go through some basic examples how you can use LabVIEW to communicate with the DAQ device. I will provide different alternatives. So here is the 3 different alternatives I will use in this tutorial. First I will use the so-called DAQ assistant in order to get data from the DAQ device. You find the DAQ assistant here in the left corner of this DAQmx subpalette. Next I will use the MAX, this Measurement and Automation Explorer, in order to configure a so-called task that I will use in the LabVIEW application. And finally I will use the so-called low-level DAQmx VIs in this DAQmx palette. By using these more low-level functions, you will get more control of the details in your code and in your application. These so-called low-level VIs are found here in the same DAQmx palette as you find this DAQ assistant. So now we are ready to start creating some basic examples in LabVIEW, and then I will create 3 different ways to communicate with the DAQ device. First I will use this DAQ assistant, then I will use and configure the DAQ settings in the MAX, and then finally I will use the low-level functions. So then it's up to you which alternative that you want to use in your LabVIEW application. So let's go to the LabVIEW programming environment and see how we can use this USB 6000X DAQ device, or if you have other types of DAQ devices, and see how we can use LabVIEW to communicate with the DAQ device and read data from that specific DAQ device that we have connected to our computer. So in these examples I will use a USB 6008 DAQ device, but of course you can use other DAQ devices from NI. So now I start by just connecting my DAQ device to my computer using a standard USB cable like this. And then the first time this window will pop up. Here you have different options. One option is just to close this one and start using it in LabVIEW, or you can open the Measurement and Automation Explorer. So either you can just go to search and type for MAX, and then you will open this NI DAQ software, this Measurement and Automation Explorer. So I just open it, I close this one. Takes a few seconds to open this Measurement and Automation Explorer. So now the Measurement and Automation Explorer has been opened, and then here under Devices and Interfaces I will get a list of all my connected hardware. Here I have my webcam. Here I have another webcam. This is the integrated webcam. This is an external webcam, and here I have my NI DAQ device called, in my case, USB 6008, and it has by default the name dev number 1, but you can easily change it by just right click, select rename, and then you can change the name of the device. If you have multiple USB 6008 or other DAQ devices, they will have, and then you connect more than one, they will get automatically the name device 1, device 2, device 3, etc. So the first thing I typically want to do is to just select this device and then type the self-test, and then the self-test completed successfully. And then I can also use this test panel, which I find here, test panel. And I can use this to test my device, to check if my analog input channels are working as expected, my analog output channels, and my digital input output channels. That I just close, and then I go to LabVIEW in order to start creating some basic LabVIEW applications. So in part 1 I want to show how you can use the DAQ assistant. So basically we have 3 different options. I guess you have also more than 3 options, but I will in this video show 3 different options. So the first option I will show now is how to use the DAQ assistant in LabVIEW, and then you will use a wizard in order to configure and set up your hardware, and then you can easily use the DAQ assistant and use it to read data from your DAQ device. So now I have opened my LabVIEW programming environment. Then I just select File and a new VI, and then I will have the front panel where I create my graphical user interface, and this white one, which is called the block diagram, where I create my code. So then I can have those like this. And then the first thing I just need to do is to, here on the block diagram, I just right click, find this functions palette, and then here under measurement IO I find this NI DAQmx palette, and then I can just pin it like this, and then I have it here. And then let's start using this DAQ assistant, which I find here. So then I just select it and put it on the block diagram like this, and then the first time this wizard will pop up where you configure which channel you want to use. So you can choose between acquire signals, that will be analog input or digital input channel. So here you have analog input channel, here you have digital input channels, and here if you want to use the analog output channels or digital output channels, then you select generate signals, and then you have analog output and digital output. But I will use the analog input, so then I select acquire signals, and I will use a simple analog input channel. I will just use the first channel in order to read some analog value from that specific channel. So then I just select analog input, a voltage signal, And then on my device, my USB 6008 device has 1, 2, 3, 4, 5, 6, 7, 8 different analog input channels. So then I just select the first one, which is analog input 0. So then I just select this one, click finish, and then this window pops up. Here you have lots of options. Typically here you need to select max and minimum voltage value. Typically I just want to read a voltage value between 0 and 5 voltage, and here you see the scale. Then typically here you also have different options. Typically I always select one sample on demand, and basically that's it. Typically you also need to select terminal configuration. You can choose between differential or so-called reference single-ended. In my example I will use differential. This means that the input channel has his own ground. So basically select the input range here in voltage, select the terminal configuration, differential or reference single-ended. I use differential, and then acquisition mode. Typically you will use one sample on demand, and then basically just click OK. And then it takes some time to configure this DAQ assistant. And now we have configured the DAQ assistant on your DAQ device, and they are ready to start reading values from that device, that specific device. So then I can go to my front panel. I can just create a numeric indicator, which I put here, and then basically you can just wire that specific numeric indicator from the output of this DAQ assistant like this. And then you have created your first basic DAQ application in LabVIEW. Then I can just click the run button, and then I'm able to read an actual value from this specific analog input channel. And then here in my test case I have a 1.5 battery, which I can connect to the analog input channel. So let's give me a few seconds so I can connect the battery, and then I will just run my application once more. And then you see I'm able to read 1.3 voltage from my battery on this analog input channel number 0. So this is the most basic way to communicate and program your DAQ device in LabVIEW using this DAQ assistant. So then let's make some small improvements in our application. So then typically here you see the output of this DAQ assistant. It has a specific data type. This is called dynamic data, while this numeric is a ordinary double. So typically you want to convert to the proper data type, and then you can use a function called convert from dynamic data. So then I just right click, select search, and then type convert from dynamic, and then I find this function convert from dynamic data, which I just double click and find it here. I select it and put it here on my block diagram, and then you have some options that you need to set. The conversion here now is you want to convert to a ordinary double scalar value. So then I just select single scalar like this, click OK, and then I'm removing this wire, and then put this small function convert from dynamic data in between here. So I can just wire like this, and now I have converted to the proper data type, which I should present here in this numeric indicator. So I converted from this dynamic data type to an ordinary double like this. So I can run it, and I will get the same value. If I connect my battery here, I'll get this 1.3 value, which is the current voltage value on my battery. So I just remove the battery and it will go back to 0. So that's one improvement. Another improvement is, of course, to show proper units and proper number of decimals. So then instead of numeric here, I can type a proper, so this is voltage, or I can call it analog input, and then I can type a specific unit, in this case voltage, like this. Or if you are reading a temperature value, you could have temperature and then in degrees Celsius. You should also set a proper number of decimals. Then I can just right click on this one, select properties, and then these properties for the numeric indicator will pop up, and here you have display format. Here I can select digits of precision. I can remove, hide trailing zeros. I can select the proper number of decimals. So I can select 1 decimal like this, and when I run my application now, I will get a proper name, a proper unit. Sorry, it's a spelling mistake here. Voltage like this, or just V like this. I run it, and then I connect my battery, and I'm able to read the proper voltage value from my battery with 1 decimal accuracy. So typically you don't need to have 10 decimals because your DAQ device doesn't have that kind of accuracy. So that's the basics when reading a value from your DAQ device. So the first and basic way to do it is to use this DAQ assistant, which you find here under functions palette, measurement IO, NI DAQmx palette, and here in the bottom this DAQ assistant express VI, which you just drag to your block diagram, and then you configure it, and then you're ready to read values from your DAQ device. Next improvement is, of course, to put this reading inside a while loop. So then I just create a while loop here on the structures, while loop, put a while loop like this. I can also right click here to see the label, so while loop, like this. And then I typically also want to create a button here on my front panel. I select Boolean, and then this stop button, which I just put here. So this is my updated front panel. I can also remove this label like this. I put it inside the loop and connect it to this connector here on the while loop. So this means that the loop stops working when this stop button becomes true. Typically I also want to have a timer, so then I just select timing, choose one of the timers. I just prefer this basic wait, which I put here, and then I just specify a constant with a value in milliseconds. So let's just set 1000 or something. So then I will read from this DAQ device every second. So now let's just run our application. So now my application will run until I click on the stop button. And now it's showing 0 because I don't have my battery connected, but when I connect my battery, it will show the value on the battery. In this case, you can see I just find the correct wires. So I have 2 wires, one on the plus part of the battery, and another one on the minus. So my battery is 1.3 voltage, like this. So this is a very simple application where I've used the DAQ assistant. I have used this convert from dynamic data, and then I present the values here in a numeric indicator. I have used a while loop and a stop button, so my application stops when I click on this stop button. can also easily extend your program if you want to read from multiple analog input channels. So let's see how we can do that, and then I just delete that part of the code. And then I just find my DAQ assistant one more time. I select this one. And now, assuming I want to read analog input channel 0 and analog input channel number 1, so then I select acquire signals, analog input on voltage, and then here I have a list of my channels, so then I just click to hold in the control button, then I can select one or more channels like this. So let's just select analog input 0 and analog input 1. So now I want to read voltage value from both these two channels. So I just click finish. I need to select the same settings here, so assuming I want from 0 to 5 voltage, I want differential, and I want one sample on demand, and then just click OK here. And it takes some time to configure my DAQ Assistant VI. So now, since I'm reading from two different channels, I need two numeric indicators like this. Here I of course need to have a proper unit, proper label, proper number of decimals, etc. But just start with two numeric indicators, numeric 1 and numeric 2. This should be the value from analog input channel number 0, and this should be the value from analog input channel number 1. So then we go back to the block diagram. I put those two inside the while loop, and then I use this convert from dynamic data, this one, convert from dynamic data. And now it's no longer a scalar, so now I select one array of scalars, most recent value, and then click OK. So I connect the output of the DAQ Assistant as an input to this function, and now the output here on the right side will be an array. So then I need to use some of the array functions. I use this index array, which is this one, and then I wire like this, and here I select index 0 like this. I just improve the visual code here like this, and then this should go to numeric number 1, which is analog input channel number 0, and then I just make a copy of this index array like this, and then here I instead of 0 type 1. So this is then analog input channel number 1 in my case, and then I wire this one to this numeric 2. And then I can run it. And in my case now I haven't connected anything on either analog input 0 or analog input 1, but I can connect my battery on analog input channel number 1, and then it should here show 1.3. If I put my battery on analog input channel number 0, just give me a second, it should show 1.3 on the left side, while 0 on the right side, which is analog input channel number 0. Of course I can improve it by adding a proper label, a unit, and also number of decimals. Typically you just need one decimal like this, and the same for this one. And then this was analog input 0 in voltage, analog input 0. Just copy this one, This one was analog input channel number 1. So now I have created a basic application where I read two values. This is analog input 0 and this is analog input 1. And I have put everything inside a basic while loop. I'm using this DAQ assistant as well. So now we will use an alternative solution. Now we will configure the DAQ settings using the Measurement and Automation Explorer. So now we have learned how to communicate with a DAQ device from LabVIEW, and we was needed to first install this DAQmx driver software in addition to the LabVIEW software, of course, and then we use this DAQ assistant, which was express VI that we could use inside LabVIEW in order to communicate and read values from our DAQ device. So this now we have tested out and made a basic example using this DAQ assistant. The next step is to, not the next step, but an alternative solution is to configure your DAQ settings using the DAQmx software. So let's see how we can do that. So now I will present this alternative solution, which is an alternative to using this DAQ assistant. I will configure the DAQ settings using the DAQmx software instead. So basically then you need to open this Measurement and Automation software. Then you can create or click on this button called Create Task, and then you will go through the same wizard that you did use in LabVIEW and this DAQ assistant, but here you use or set up your hardware in the Measurement and Automation Explorer instead. So let's see how we can do that. So now I open my Measurement and Automation Explorer. I select Devices and Interfaces and select my hardware, my NI USB 6008 DAQ device in my case, and then I select just Create Task here, and then this wizard pops up, which is the similar as the wizard which we was using in LabVIEW and in the DAQ assistant case. So now I want to just read one analog input signal from analog input channel number 0, so then I just select the same as in the previous example. I select Acquire Signals, I select analog input and voltage, and then the same 8 channels are popping up here. I select analog input channel number 0, click Next, and here I need to specify a name for my application. I can select it or type whatever I like. I can just type my voltage task number 1 or something, and then just click Finish. And then I can also test my configuration here, or I can go to LabVIEW. So let's just open my LabVIEW program, which I have here. So now I just want to read on this analog input 0. So then I don't use the DAQ assistant more, so I just delete the old code like this. And now I need to go to this DAQmx subpalette, which I find here, and then I need to select this task constant. I put it in here, and then here in the drop down menu I just select the task that I have created. So my task was called my voltage task 1, then I just select this one. In addition, I need to select this DAQmx read function, which I just pop and put into the while loop here. I can show visible items like this, and then basically here it has an input. If I click Ctrl H, you see the inputs and outputs on this DAQmx read function. Also here in the bottom you select analog, single channel, sample, and the double data type. And then I just wire this task selector to this input called task channel input. And then here on the right side we have data. So basically I just wire the data output directly to my numeric indicator, which I have here. And then I'm actually finished with my application. I can now just run it. And now it shows 0, but if I connect my battery, it will show the voltage level on my battery, which is just give me a second to configure and connect the battery. Yeah, of course here in when I set up the task here in my measurement and automation explorer, of course I need to use the same values here. So from 0 to 5 voltage differential, and then on sample on demand, like this. Click on the save button, and then go back to the LabVIEW program, and then run the application. And now it shows 0, but when I connect my battery, it should show 1.3, which is the voltage level on my battery, like this. So this is an alternative solution that you can use instead of using the DAQ assistant. And also there may be some improvements in this application as well. So assuming you read lots of values and you want to read them very fast, then you could optimize your code. So then I could add some functionality to my program. So instead of only using this DAQmx read, I can also use some other functions here. I could use this DAQmx start, which I could put here on the outside of the loop on the left side, and then I can connect this DAQ task name to this function. I show the visible items label, so this DAQmx start. I connect the specified task which I have set up in my measurement and automation explorer, like this, and then the output here, task out, should then go to the DAQmx read, like this. And then on the right side, outside my while loop, I can also use this DAQmx stop, which I find here. And I could also use this DAQmx clear task, which I find here. So then I just select the visible label, like this. Then the output of this DAQmx read, task out, should then go to the input here on this TaskMX stop task, like this. And then the output of this one should go to this DAQmx clear task, like this. So now when I do like this, I put the configuration on the start task on the outside the while loop, so this is only executed once. If I have it here inside, it will be executed in every iteration. So typically you want to have this operation on the outside, on the left side, and when you click on the stop button here and the while loop stops, you should also stop the task and clear the task, like this. You could also wire this error cluster. So here on the DAQmx start task, you have error out, which you could wire to this one, and then the output of this one could go to the DAQmx stop and further to this DAQmx clear task, like this. So now you have created a more robust application that deals with error handling, and you have also increased the speed because the configuration of the task is put outside the while loop, and then only the reading is done inside the while loop, and then clearing and stopping the task has also been put outside the while loop, like this. Let's just run the application. It should work in the same manner. So now it shows 0 voltage, Then I connect my battery, and then it shows 1.3 voltage. I remove my battery and it goes back to 0. And then I can just stop it in order to stop the application. So this is how you can make a basic LabVIEW application where you in your Measurement and Automation Explorer has specified the task and the configuration of the DAQ device here in the Measurement and Automation Explorer, and then you just select the name that you have created here in this task constant, which you find here, and then you wire it directly to the start task, and then the start task is wired to the DAQmx, which is reading the proper value, and then you just stop your application, and then you stop and clear the DAQ device like this. So now I will show an alternative solution using this so-called low-level DAQmx VIs, which is part of the DAQmx palette. So then first we started using this DAQ assistant. I guess this is the easiest way to configure and start using the DAQ device in LabVIEW. Then I showed an alternative solution where I configured the DAQ settings using the Measurement and Automation Explorer, and then used that configuration in my LabVIEW program. And now finally I will use the so-called low-level DAQmx VIs in LabVIEW, where you, by using those low-level VIs, will have more control or full control of all the details in your application. Then I'm back in the LabVIEW. I have an empty or blank VI here. I have the front panel here and the block diagram here. As in previous example, I just want to read numeric value from my DAQ device and an analog input value in voltage. So then analog input 0 channel I want to read like this, and then the unit is in voltage like this, and then you have the numeric indicator here, and then I just right click here, go to the measurement IO, NI DAQmx palette, and this so-called low-level VIs is here, and it's some of the sub palettes here. The first thing I need to do is to use this so the first function I need to use is this found here in this palette, task config control, this create task. So DAQmx create task, which is the first function I need to use. So basically this just create the tasks, and then I need to go one level up here under create channel. So I need to use this DAQmx create virtual channel, which I put here on the same line. I just right click also here to find the label, and then I need to connect those two together. So the output here, task out on the right side, which you see here. If you click Ctrl H, you will get this help window. So task out should go to task in on this DAQmx create virtual channel like this. You have also different options. You have analog input channel, you have analog output channel, digital input, digital out, etc. And I will use this analog input and voltage. So I select this one. But you have lots of other options that you can use depending on which channel you are using. So the next step, I need to specify which physical channel I need to use. So then I here on this help window, you see this DAQmx create channel, virtual channel has lots of other inputs. One of the inputs is physical channel. So then I can just find the proper input, right click, create a constant like this, and then I'm able to choose the proper channel. Another solution is to go here under advanced, select IO constants, and then select this one, physical channel constant like this. So this is the same one. And then I can select the proper channel. So I will use device number 1. Device number 1, as you remember, is the name that you find in the Measurement and Automation Explorer. So let's open Max. This one. So my device number 1 is my device I have here under Devices and Interfaces. And this one. And of course I can change the name to device number 2 or a more descriptive name. But I just use the default name, and then it will pop up here. And then I will want to use analog input channel number 0, so I select this one, and then this physical channel is just wired to this one, like this. So now I have created the task, I have created a virtual channel, I have selected the proper channel here in the list. The next thing I need to do is to actually read from the channel. So then here in the DAQmx palette, I just find this DAQmx read, which I put here. I right click to find the label, and then this one has an output, task out, which goes to task in here on this DAQmx read, like this. And then basically I can just connect this numeric indicator directly to this one, like this. Sorry, this was the wrong input. You see, sorry, the wrong output. So it has task out and data. So I need to use this data and connect it like this. Here you can also select the proper data type. So I select analog, single channel, single sample, and double. You have other options here if you use multiple channels, etc., or digital channels. But I will use analog, single channel, single sample, and then double. And basically that's the first draft of our application. And then I can just run it. And now it shows 0. And also show proper number of decimals here. And then I also need to connect my battery before I run my application. So now I connected a 1.5 voltage battery that is used, and then I run it. It shows 1.3 voltage, like this. And the next step now is, of course, to put this inside a while loop. So then I find the while loop, drag it like this. I create a stop button, which I find here. And then I wire the stop button to this loop condition in the right lower corner. And then I need to use a timer. I use this wait function. I right click on the input, create a constant, for instance 1000 milliseconds, so that I will read a value from the DAQ channel every second, like this. Now I can run it. I haven't connected anything, but now my application is running continuously until I click on the stop button. So then let's just connect my battery like this, and now it shows 1.3 voltage. So now I remove the wires, and then it goes back to 0. That's how you use these low-level functions, but let's see how we can improve the code even more by putting this create task outside the while loop, and also have some stop task, clear task here on the right side of the while loop. So then I start by just removing some wires here. Then this part, I want to have it outside the while loop on the left side. Then I just make the while loop a little bit smaller, like this, and I have this part on the left side of the while loop, where this is where I set up and configure the channel and the DAQ device. So this should only be done once, and it can be done outside the while loop, like this. And then I wire it to this DAQmx read. Like this. And then I want to stop the task, which I put on the right side of loop when the loop stops. So then I find the DAQmx stop task, which I have here. I also use this DAQmx clear task, which I put here. And then the output task out here on this DAQmx read goes to this one. And then it finally goes to this clear task like this. Now our application has become more robust and also faster, because the configuration is only done once outside the while loop, and then only the reading is inside the while loop, and then when you click the stop button, the task will stop and the task will clear outside the while loop like this. You can also wire this arrow cluster, so in each function there is an arrow out that you should put on arrow in on the next VI, and then arrow out goes to the arrow in, arrow out goes to arrow in, and arrow out goes to arrow in, like this. So let's just run the application now. Now it shows 0, and then I connect my used 1.5 voltage battery, and then hopefully it should show the same value as in previous examples, namely 1.3 voltage, like this. This is more or less our final application, where we have used low-level DAQmx functions in order to configure and communicate and read data from our DAQ device. We can also add more configuration if needed. So here in this DAQmx create virtual channel, you see it has lots of inputs to this function. You can set the minimum value, maximum value, as we did in this wizard earlier. You can also set units, etc. So then basically let's set the minimum value to be 1 voltage, to be 0 voltage, and the maximum voltage to be 5. So then I just find this proper channel, the proper function inputs. So this is the maximum value. Then I just right click, create either a constant. Of course I can also have controls here on my front panel, but let's start with have it here on the block diagram. So this is the maximum value, which I can set to a specific voltage value. Typically I just want to read from battery, and then I can set between 0 and 5 voltage. So then next, the minimum value, right click, create constant, like this. I can also show the label. So this is the minimum value, which I set to 0, like this. So now I have minimum value and maximum value. I have also other inputs I can set. I can set the units. So let's find this one. It's here, units. Then I just right click, create a constant. I could also create a control, which I could have here on my front panel. But then I select a label like this, and then here I can select the proper units, typically voltage or other types of units, depending on the configuration I set here in this drop down. So now I have selected analog input voltage. Then typically you select voltage here. If I select something else, analog input temperature or whatever, you typically want to select another unit. So that's how you can set additional configuration on this DAQmx create virtual channel function. And our application, when I run it, should work in the same manner. So that's all for now. So now I'm hoping you are able to connect your DAQ device and use it in LabVIEW, and then you can choose between different alternatives. So then good luck and thank you.